Good morning, everyone, and welcome back to the class on smart materials and structures. To go up with, we have covered almost the case studies related to each and every module. So, one thing what I found which was not covered was related to the optical fiber sensors, which we have in our vibration absorbers module, right? So the main agenda of the application is how these optical fiber sensors are used to detect the cracks. Okay, so related to that, I just found an case study wherein it helps you to understand the importance of optical fiber sensors other than that of other type of sensors, right? Why it is being used. So, related to that, it is a huge case study. I'll be just briefing out the important steps, and remaining thing I'll be sharing you to the Google Classroom. You can go through it. Because if they ask you anything in practical with respect to an example to explain, you should be able to know. So, the real time application related to each field is very much essential. In this aspect, here you have a research article on embedded distributed optical fiber sensors. Where it was used in reinforced concrete structures. So this is focusing on an civil structural applications, a case study, right? So which was published in 2018. So you know that sensors are everywhere throughout the world. It has its own market. And what's the difference between using an optical fiber sensor and other sensors? The other sensors also you have studied with respect to any class of material of smart or sensors could be developed. So what is the importance of this optical fiber sensors? So that also I've told you what are its applications, right? How it is used to detect the crack. All these theoretically we have studied. So now little bit of focus is done with respect to an example point of view. So here it is basically a case study wherein they have used this optical fiber sensors in reinforced concrete structures. Means basically an buildings, any type of building which has been constructed by using concrete material. So using these sensors have proven that it is more better, okay, for protection requirements. Usually, when you have a building which has been constructed, you will be having a set of engineers who are well experienced and they will use some set of equipments to claim how good it can stand for a number of years. Suppose some construction might have a life period of 100 years, some might be having 150 years. How do they evaluate? By having some theoretical aspects, some measuring parameters through which they regularly measure and let you know, right? So, apart from doing this regular interval of check, if you have this optical fiber sensors, so this will easily help you to identify even a single crack if it is formed on the wall. And hence, in theory, you have studied, it's been used for optical fiber sensors in case of crack detection. So, same thing is being focused over here. So, this optical fiber sensor plays a very vital role in protecting the entire structure, right? And also it provides a very accurate measurements both in case of uncracked and cracked stages. So it will continuously monitor and say that there is no crack penetration from this time to this time and suddenly a crack came into picture. So that also they are provided with a very good amount of accuracy. And apart from this, the optical fiber sensors are also able to measure the loading and unloading bearing capacities. And hence you have a many amount of plus points in using this distributed optical fiber sensors. These are in short called as DOFS. So mainly in this paper, they have checked how the crack is coming out for loading conditions, right? So if it is a 3 point loaded condition and at unloaded condition, how was the result? So they have just expressed the measurement of these data by using optical fiber sensors for loading and unloading conditions, and they have documented the results, and they have also claimed that the measuring parameters which were measured was really accurate, so that before the damage the equipment can realize when it could may be and scrap, when it could be demolished, and hence until that period of time it helps to claim what is the reliability of that particular building, where a human can stay relaxed without any tension. Usually all building structures nearly of 7 to 8 floor building have a life of 100 years. If it is like 14 plus 23 plus floors construction, then again the maintenance is very much essential, and you cannot regularly make a person to stand and check what's happening, right? So in these cases it is very much essential to go with optical fiber sensors. I hope the abstract part is clear enough. Any doubt in this?
No, no.
Okay. So in this aspect, we will come down. Is my screen changing? Yesterday you had a problem of it was not changing. Is it visible for you guys?
Yes,
Okay,
ma'am, it's
okay.
visible.
So in this regard, see this SHM, even we have studied. What is SHM? It is structural health monitoring, right? So structural health monitoring of any building is very much essential. Previously, it was done in a different way, where you used to have the engineers who used to measure, right? And check when and where you will be having a problem in any building constructions, right? So now it is not the case. So now we have a new concept of optical fiber sensors, so which helps in what we say in protecting the civil structures, and hence it is very much essential for you to understand what is the importance of this optical fiber sensors. So that we will be going on related to the sensors now. Okay, so basically previously used to have the engineers who used to study what are the measuring parameters, how and where you can check the health monitoring system, right? So when the building can collapse, all those aspects. So it was done in that way. But now it is not the time to go accordingly. So what we have to do here is basically it depends upon what is the individual experience and background when you can claim that it is a safety condition assessment. So all these things he has to measure. Okay, so this is an really an cumbersome process which takes a huge lot of time period, and hence it is a very easy way to go with our optical fiber sensors. So regular practice approaches, even though if there is no human being intervention, only one experienced engineer also, they need some measuring instruments. So what were the measuring instruments they used? It was like electrically powered sensors. It is not optical one. It was the electrically powered sensors what they used. Okay, such as strain gauge sensors. Apart from that, they were in need of inclinometers. So this is one of the measuring instrument which helps in checking the health condition, how good the wall, the ceiling of the wall is, when it can result in the formation of crack, how it is affecting with respect to external environmental conditions. So all those things have to be measured. Okay, so apart from that, they needed an transducer to check what is the displacement the building is getting with respect to the its stand of position for so many years. Okay, similarly accelerometer and many things. So again, it is an cumbersome process which needs to be taken care. So it is like not an very practical thing to carry on with the previous techniques. And these techniques had some shortcomings also. And it was not so accurate and precise, the data what we were getting. So there was a call to find out an alternative one. So in that sense, this optical fiber technology came into picture, wherein we can use this optical fiber sensors for the same measurement of the conditions of the structure, right? In these aspects, these sensors were developed to check the structural health monitoring. So this was the need why this structural monitoring with respect to the optical sensors came into picture. So I told that previous techniques had many shortcomings. So how these shortcomings were overcome by this optical fiber sensors? So it had some advantages. So what were there was some inherent advantages was the optical fiber sensors presented. Okay, so they had, so when the results of these optical fiber sensors were compared with that of the electrical based counterparts, so what they found was the resistance to electromagnetic interference was very much good in comparison to that of the electrical sensors, and the durability aspects were good, and it had more immunity to the corrosion than that of the other type of measuring technique, which is nothing but the electrical sensors. So they were able to evaluate each and every fluctuations which is coming. So fluctuations not only with respect to the temperature, right? So even with respect to the atmosphere, so everything was able to identify even when they were in very small size. Some things what happens is if you use the electrical sensors, they can able to manage and get the data and the results what it has sensed when there is a major change, right? So you need to have the sensors who is able to detect even a small minor change which happens into the structure. So it could be a small crack, it could be a small variation in the temperature or a small variation in the atmosphere. Even that small change, it has to be sensed. Then only you can get a very accurate and precise data related to the reliability of that particular structure. So this eye accuracy of sensibility is not present in electrically powered sensors, and hence the availability of this optical fiber sensors helped in a larger extent to measure the structural health monitoring of any buildings which are constructed, right? So this was a need. And one more thing, the sensors what which has been developed through optical fibers are still light in weight in comparison to electrically powered sensors. And also these optical fiber sensors are available in very small size in comparison to electrical power sensors. So you have many plus points in comparison to electrical power sensors, and hence it helped in a better way to measure the health monitoring of any constructed buildings, right? For that many type of we have studied different class of optical fiber sensors. If you remember, one of it is fiber Bragg grating sensors, right? So in common, in general, frequently this fiber Bragg grating sensors, which is under a class of optical fibers, are being used in popular to measure all the aspects of the health monitoring condition for a given constructional building. Okay, so this is the need why this optical fiber sensors are used. So once you know the difference, I think now the difference between a regular electrical sensor and an optical fiber sensor and what is its importance is clear enough, why it has been used.
Yes, ma'am.
Yeah, you should be able to identify the need and differences of the sensors which are available. So then it will be available, then it will be understandable by you to know which type of sensors to be used when in actual requirement. Okay, so when we use an optical fiber sensor, right, for measuring the health monitoring condition, you will be usually using an standard monitoring practice. You cannot blindly select your own monitoring practice. Sometimes in an entire day of 24 bar 7, somewhere in the morning once you will check, in the afternoon you will check, and in the evening, not like that. A pre-scheduled monitoring task has to be assigned, and you should be having n number of points. It is not like, suppose if you are measuring the monitoring condition of a building, if you just locate one point sensor, suppose one optical sensor at a particular location, so that will not help you to get the data related to the entire building. Every building will be having n number of floors, right, n number of rooms, n number of flats, yeah, apartments, yeah, if it is a office, n number of departments, right, a common wall, many things will be there, common area and all. So you should be having different locations wherein you drop this optical fiber sensors, right? So that has to be represented by means of a global structural behavior. So if you are a civil engineer, you will come to know what is global structural behavior. How the structural behavior will be, that you should keep in mind. How does it change with respect to external environment? How the effect on the walls will come into picture as the structural age increases. What could be the regular life period of a given structure? So when it will be in a younger age, when it will be in a medium age, when it is termed to be is an older age, similar like that of a human being, when it could have the chance of collapsing down, right? All these are nothing but the global structural behavior. Why it is called global structural behavior? Because you have a standardized strategy which has been developed for global, for the structural behavior. So you have to refer to those standard structural behavior based on which is the number of floor building you are referring for. So based on that, to analyze the behavior of those structures, you have to place different optical fibers at different location, and all these optical fibers sensors will be located through a sensor node. So the data accumulated from that will be transmitted to an controlling unit again, right? So it will analyze, the controlling unit will receive the data, it will analyze, and it will check whether the health condition of it is good or not. How will it will claim it is good or not? It should be having some database in it, in the software. So that database will be provided by the global structural behavior. If it is mapping with that continuously, suppose you are starting the structural behavior right from the day one when the building is constructed. On the same day, no building will be having any problem. So no need for you to check also. But still, without the intervention of human being, if you have just embedded the sensors where you have to do it, and if it is connected through a controller unit through the sensor node, what happens is you will be monitoring it just on the system. So if some person is being assigned to check the conditioning of it, every day he will just go through the progress which has been shown in the software. So he will report to the concern like it is going on smoothly, no problem. When he is monitoring, if something sudden has happened in the data, if there after like around 50 years, if a crack has been originated, so he'll come to know that the problem has started in the building, and it can also map how long it takes for the problem to be a major issue. So they can put forward this to the society people within this time period. All these damages has to be overcome, or else the building get collapsed, right? So all these things could be taken care. So this is the thing why it is very much essential. Okay. So in these things, these optical fibers sensors are used. A distributed optical fiber sensor, it is named because you might need more than like around It is not like 10, 15. More than nearly depends upon the size of the building. You need many optical fiber sensors, right? So this is the place where you will locate and identify if any problem occurs. Suppose if you have constructed a building, when you construct a building, you need many materials to come together. It is a combination of different materials. So you say that it is a heterogeneous mixture of many materials like concrete and also some other essential elements. If it is not mixed properly, it can also result in cracking and corrosion in the beginning only while plastering, right? Every civil engineer will be knowing the actual composition in which all the components of the mixture are mixed. If it is not mixed as per the proportion, so when you apply, right, it can result in formation of crack. And if the composition is not proper, it can cause a result of corrosion easily in a short period of time. So even in the initial stage, if it is not worked properly, this optical fiber sensors will help you to identify what is the problem it is coming across, because it is very sensible to identify even a very small crack, and hence optical fibers are used in many of the civil engineering applications. So this is the need of optical fiber sensors, wherein the regular electrical sensors cannot do this type of work, right? So you know the application of it and advantages also. So these are the advantages of optical fiber sensors and why it is being used. And moreover, in your syllabus, you have that optical fiber sensors are mainly used to detect the crack, right? So this is a diagram which helps you to show the distribution of the crack and how it is been identified with the help of optical fiber sensors. Okay, so this is an optical fiber sensor. Means an optical fiber sensor is called as a point sensor because you are locating that at a particular point, and this optical fiber sensor will be very small, right? And hence we also call that as a point sensor. If it is claimed to be as distributed sensor, you will be having n number of optical fiber sensors which are embedded along some common line. If that is the case, then you say it as a distributed sensors. We usually go with point sensors where the number of sensors needed is less. Suppose if you want to just locate the crack which is coming into picture in a single room. Suppose you have a shop, and if you want to locate the point sensors only for your shop, then it is no need of going for distributed sensor. If you just locate the sensors at different points, you can able to identify where the crack is coming into picture, right? But if it is a huge multi-story building, you cannot go and keep on pasting the point sensors here and there, collecting the data from it and segregating and doing analysis. It takes a long period of time. In that case, we go for distributed sensors, wherein you will be having a continuous integration of many optical fiber sensors. So this is a difference what you have to know. So in both the case, this optical fiber sensors will be connected to an circuitry system where you'll be having a controller unit. It will be nothing but a remote monitor. So you'll be having a software. So when it is connected, so what happens is any variation, if any strain is induced, right? So if it is high, it results in the formation of a crack. And what is the magnitude of the crack which is coming in, so that you can identify. So here the amount of strain across this point is higher in comparison to these two. So that you will get to know in the monitor directly the magnitude of strain which has been caused. So if it is very high, then it also shows it has an unbearable strain which is induced, wherein the crack can penetrate and move from one end to the other end very quickly and result in the formation of fracture, yeah, whatsoever the other damages to the building. So the person will become, what do you say, he will just take a call. What is the decision to be taken? How to overcome this? How to safeguard the building and specific room or shop. Suppose if it is done for the same a multi-story building, so it will provide you the peak values at some position wherein you have the maximum strain values, okay, across the length, wherein you have added this optical fiber sensors. So this will help you to identify where you are getting the highest strain effect, how it can be reduced, because you cannot retain these cracks for longer period of time. It has to be healed out, right? So then the plastering of the crack and repainting, all thing has to be done so that the building will be safeguarded. So if all these things are checked automatically by a monitoring system, then the visual inspection of the engineers regularly with many instruments for measuring, all these things could be reduced, and the time of the engineers can also be saved. So this is the reason why these distributed optical fiber sensors are used. And we have one more diagram here to see the comparison used in between two type of sensors. So this is about the point sensors. So you can see n number of sensors which are located. Okay. And you have an distributed sensor here, a continuous distributed sensor throughout the channel of the cable here. Okay, so wherein this is a cable wherein n number of optical fibers are connected at different points. So you can analyze which yields more result. So here they have given a comparison between both the type. So you can use any type depending upon your requirement and depending upon how complex is the building, right? So based on that also you should think about, if it is a very huge building, you cannot go with point sensors, point optical fiber sensors. You have to go with distributed continuous optical sensors in that case. So if you go with a distributed optical fiber sensor, so what is the plus point is it will be sensitive across each and every point. Okay, along the entire length. So any variation in any point, so it will be able to detect. It could be a crack or it could be any variation in the external surrounding, right? So anything it can sense very quickly and it can reveal the data, right? So this is the plus point. So that entire sensed data will be transmitted to the reading unit. So this reading unit will receive the sense data and it will transfer to the controlling unit. So where it converts the input data into readable machine language, right? So then that instruction will be passed on to the actuator and it works accordingly. And even though if it is of a very long distance, okay, so for the several kilometers, this type of continuous distributed optical fiber sensors could be used successfully. Okay, and a reading unit cannot be too long. It can be within few kilometers. So the reading unit will be connecting. So you'll be having a single cable unit wherein you can connect to the reading unit. So this is an example wherein you are using an distributed optical fiber technology. Suppose if you are using an point sensor, so what is the differences? You similarly to this, you'll be having this point sensors throughout the area, but you will be able to detect and sense the variation which is happening in this particular point only. If anything is happening in between, you will not be able to identify what's going wrong over there. So it won't provide you so much accurate results as per that of our distributed optical fiber technology. So this is a difference between these two, right? But wherein the data what you receive, again it has to be transmitted to the reading unit. so that the sensed data will be transmitted to the reading unit and it will again convert it into the machine readable language, the binary, the 0 and 1. Okay, but here this was very simple. This connection to reading unit was done with a simple cable, right? A single connecting cable will work on. But wherein here you need to have a complex connection. Why complex connection? You have n number of sensors, right? So all sensors, all point sensors are providing some data. So all this data has to be segregated, right? So for that you need to have a sensor node. So this is one sensor node, this is one sensor node, this is one sensor node. So it will connect the data from each sensor. So this is a hub here where you have one sensor node. So this is a second hub where you have a second sensor node. So this is a third hub where you have a third sensor node. So this data will be collected. It is not like a single node will collect the data from all the sensors. It is highly impossible. Every node will be having a capacity to bear some amount of data, so it can able to store only that amount of data only. So if it is anything crossing more than that, it is highly impossible. So minimum we usually connect across 6 to 7 sensors to a particular sensor node. So here I don't know how much they have connected. 1, 2, 3, 4, 5, 6. Okay, here it is 6 only, as I told. So every six sensors will be connected to a single sensor node. So the data will be stored here, 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 and here. And to transmit this huge amount of data, which is bifurcated into different nodes, it needs a complex connection. It is not like with a single cable you can transmit to the reading unit. So you are gathering the data through different bunch of sensors, and these data has to be safely transmitted to the reading unit so that it converts into the required language, right? For that you need a complex connection. So this complex connection could be achieved by large number of cables, and it cannot work in with a single cable as it was in the case of distributed optical fiber technology. Okay, so this is the thing what you have to understand. And if you go with a distributed optical fiber system, it might be like a little bit complicated and an expensive part in developing the IT infrastructure. Have you remembered about the IT infrastructure? So this is usually done through optical fiber. Suppose you have a huge building wherein you need to make a hub wherein the data could be shared from one up building to the other, right? So you need the router configurations and you need the IT infrastructure, wherein this IT infrastructure will be developed by these optical fiber sensors. So you'll be having this optical fiber sensors throughout the line of the huge building so that the data could be transferred, accessed, and edited from one center of the company to the other center or to the same center. So there are many classes of IT infrastructure. So even in those they use this optical fiber sensors. So if it is a small building or a small room, you can go with this point sensors, or else it is not advisable one. We usually go with distributed optical fiber technology. So this is the difference between the two type of optical fibers. Any doubts associated with this? Are the things clear?
Yes, ma'am.
Okay, okay. So you know now the difference between just a optical fiber sensor and distributed optical fiber sensor. So if we speak about distributed optical fiber sensor, this can measure the variation in the strain or even the variation in the temperature. It is not for a specific point. It is like to know the variation across their entire length. Okay, so why we are speaking about the entire length? Because we are using the optical fiber in which the light has been scattered throughout the entire pipe of the optical fiber, and hence any variation which is happening either due to the strain or measurement could be easily monitored and identified in any structural element. So this is the main important feature of any optical fiber. I think this has been aware enough for you already. So based on that, related to these degree of distribution, distributed optical fiber sensors, many researchers have worked and shown that this type of optical fiber sensors could be used for different applications. In that, they have focused on crack monitoring also. Suppose sometimes what happens is there'll be a very mild crack which has been caused on the concrete of on any building, so that crack will be monitored continuously until that crack will propagate and cause a harm. Okay, and also after identifying the crack, one can think over how to overcome the crack in that particular location. So what is the advisable paste to be applied on the crack so that the crack will not propagate further, so that the reliability of that particular building will enhance. So in this way you have to study and analyze the verification. So similarly, apart from this, many high performance of the concrete material which is being used, what are the geotechnological engineering applications, how it is being used in monitoring any concrete structures. So all these things are analyzed by different research papers. So here these are the citations which are being given of different researchers. So if you go through these research papers, you will come to know exactly how they have analyzed. Okay, so when it comes to optical distributed sensor, so usually I told we'll be having a controller unit. So this will be nothing but an monitor, remote monitor, in which you'll be having an controlling software. The commonly used software is ODISL. Okay, so this is an software which has been used to monitor continuously what has been happening. It is not like it is necessary for you to stay there for 24 bar 7. Just connect it to the a controller. Okay, so any variation it will be showing. So this is the graph which is showing. By looking the graph you can see whether you have any high variations or these variations are acceptable with are within the range, so that you can be without any tension. So this controller software plays a very vital role. It cannot be used by a common layman. He has to be trained related to operating the entire equipment. Okay, so here you will be having an optical fiber optics switch. So you can on and off the functionality of a fiber optics switch. So always we should see that this is being on. So below this you will be having an optical distributed sensor integrator, because you need an integrator such that the sense data will be transmitted to that of the monitor. So once it is monitored, once the instructions are been developed, again this has to be connected to an actuator. So that will take place. So this is how an optical distributed sensor and the optical switch works smoothly with the help of an controlling unit. So if they ask you, you should be able to write in your own words about its importance and what are the measuring parameters, how you will measure it, everything you should be clearly understanding. So this is the entire glimpse of importance of optical fiber sensors, and also now you are aware about the difference between the distributed and the regular optical fiber sensors, why it is being used, right? How it is being used, what are its applications, so how it has a better point in comparison to electrical sensors, right? So what are its plus points, so where and all you can use, how does it operates basically, what is the difference between a regular optical fiber sensor and a distributed optical fiber sensor, so how it helps in reading the crack which has been generated. All these things we have analyzed. Right. So apart from that, there is an experimental part also which has been given how it is operated to check the structural health monitoring condition of any structure. So you can go through this experimental part by yourself. Any doubt, I will explain to you. And in experimentation, they have used this distributed optical fiber structures with respect to strain gauges also to measure what is the strain which has been induced when it is subjected to an tensile test. See, a specimen can be subjected to an tensile test or compression test, right? So, due to this type of testing, obviously some strain will be induced. So that strain usually we measure by using some type of sensors, and one of it is strain gauge sensors. So the data is measured by using the strain gauge sensors, and also it has been measured by using distributed optical fiber sensors. So both the results are compared, and it was observed that this distributed optical fiber sensor data is more precise and accurate than that of the strain gauge sensors. So we can claim that the data what we get through distributed optical fiber is also of what we say accurate and very precise value, so that we can rely on the data for a longer period of time. So that you have to understand. So once the experimental data is done, they have also compared by using the abacus or the ANSYS. I think this is not abacus, it is the ANSYS software. Okay, so they have measured the tensile measurement variations, and they also have compared the strains which are being induced in both the type of sensors with respect to the load, how the strain is being varying within the given object. So this also is being identified. Okay, so this is how they have done the tensile testing for the concrete structures by using distributed optical fiber sensors. So they have checked experimentally and analytically, and they have compared the results also. So that was for tensile test. Similarly, they have done the load testing on reinforced concrete beams, and they have analyzed it both experimentally and analytically, and they have seen how the variation will come into picture. Okay, so this is how they have shown the improvement, how what happens when it is subjected to unloading, right? And similarly for this beam, they have subjected for loading conditions. So when it is subjected for specific loading condition, what will be the action which is taken place in the cantilever beam, whether bending is happening or something else. So this verification has been understood by drawing the plot with respect to load versus time. So what is the maximum load it can bear with respect to the time period when the load bearing capacity was very less, at what particular time, that also could be known. So this is how they have drafted a paper very beautifully for the clear understanding of importance of fiber optics sensors. Okay, so if you go through this entire paper, you will be able to know the gist and information in depth. What is the importance of optical fiber sensors? Why it is mainly used in crack detection? So we have covered all related to the theoretical approach. Only thing now we are mapping with respect to the practical aspects. So I have covered almost like 60 to 70% of your research paper related to this. So remaining part, you can just go through it. So it will be very clear for you to understanding. It is written in simple language. Now, if you have any doubts related to this case study, you are free to ask me. Any doubts?
No more.
Okay, so this is how we have covered almost all the what we say the case study related to all the modules, and overall a general case study combining all the modules also. So It's fine then. So next Monday we will be meeting with the subject seminar. Please prepare it accordingly. Everyone, it is mandatory that you will prepare the PPT and present it as per the schedule and timings given. No bunking is expected. You have marks assigned to it of 10. See that you will present. So after presenting, you are requested to upload that PPT to the Google Classroom without fail. Without uploading this PPT, the marks will not be assigned. Be careful, prepare the PPT. Any doubts, you are always free to call me at any time. Okay. So,
Okay.
yeah, Sandesh.
No, understood.
Okay, okay. So now everyone kindly type your name and USN in the chat room. I'll just take the attendance. Danush,
Yes, ma'am.
Rithun, Mithun. I think he's there. Mithun, Mohanambal.
Yes, ma'am.
Okay. Sandesh,
Yes, ma'am.
Srinidhi.
Yes, ma'am.
Okay. Sukrut,
Yes, ma'am.
Sri Harsha.
Yes, ma'am.
Who has not answered me the attendance? Srinidhi, have you joined twice?
Ma'am.
Huh?
Yes, ma'am.
Why?
One by system I have joined, ma'am. Like
Oh,
for
okay,
present
okay.
the
Yeah,
system.
yeah, 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 fine. So since the number here was seven and I could have only six, so I thought that Mithun is there. So I just asked you.
Okay.
Okay, fine. So everyone take care. Have a nice day, good day. Prepare well for subject seminar. See you on Monday again.
Yes,
Thank you,
ma'am.
ma'am.
Thank you.
Yeah, yeah. Thank you. Bye
Thank you, ma'am.
bye. Yeah, thank you.